There is a measurement neuroscientists use called cortical thickness. In adults who used smartphones heavily between 2017 and 2024, that measurement changed, not metaphorically, measurably. Your brain physically rewired itself, and nobody sent you a notification. You have probably heard the word neuroplasticity, maybe from a self-help podcast, maybe a wellness ad, and by the time you heard it, it had already been watered down. Here is what it actually means in neuroscience. Neuroplasticity is the brain's ability to reorganize itself structurally and functionally in response to experience, learning, and environment. That sounds clean, but here is the part nobody tells you. It works in both directions. Your brain is not passively recording your life. It is actively sculpting itself based on what you repeatedly do and equally what you stop doing. Hebbian theory, formalized in 1949, puts it this way: neurons that fire together wire together. But the reverse is just as true. Neurons that stop firing together unwire. If you want proof that experience physically reshapes the brain, look no further than London taxi drivers. In the year 2000, neuroscientist Eleanor Maguire and her team at University College London published a landmark study in the Proceedings of the National Academy of Sciences. They scanned the brains of 16 licensed London taxi drivers, men who had spent years memorizing the knowledge over 25,000 streets and 320 routes in one of the most complex cities on Earth. The posterior hippocampus, the region associated with spatial navigation and memory, was measurably larger in taxi drivers compared to controls. And the longer a driver had been working, the larger the growth. This was not a metaphor. This was volumetric brain change, visible on MRI, driven entirely by what these people chose to spend their time doing. The hippocampus is your memory archive, your spatial map, your sense of where. Stress it, challenge it, feed it complexity, and it grows. Now here is where it gets uncomfortable. The prefrontal cortex, the region directly behind your forehead, is your seat of executive function. Decision-making, impulse control, the ability to think about the future. And in a 2023 study published in JAMA Pediatrics, researchers found that children who spent more than 3 hours per day on social media showed significantly faster thinning of the prefrontal cortex compared to lower-use peers. Now, thinning is a normal part of development. The brain prunes what it does not use. The question is, what is it deciding not to use? When your attention is constantly fragmented, pulled between 6-second clips, notifications, likes, the brain begins optimizing for that environment. Deep focus becomes expensive. Boredom becomes intolerable. Delayed gratification becomes foreign. By 2025, a follow-up analysis in Nature Human Behavior confirmed these patterns extended into adults who began heavy smartphone use after the age of 25. This is not a children's problem. This is a human brain problem. In early 2026, the journal NPJ Digital Medicine published a paper that stopped a lot of neuroscientists mid-sentence. The study examined brain activity patterns in participants who regularly used AI assistants, chatbots, recommendation engines, decision support tools for cognitively demanding tasks. Their finding, passive AI use, where the AI provides the answer and the human simply accepts it, significantly reduces what researchers call activity-dependent plasticity. In plain English, when you stop wrestling with hard problems, when you outsource your thinking, your brain stops building the circuitry needed to think independently. The authors were careful. They did not say AI is bad. They said how you use it determines what happens to your brain. Active engagement, questioning, verifying, building on AI output preserved plasticity. Passive consumption did not. Let's be precise about what has shifted. Pre-smartphone, the default state of a human brain was something neuroscientists call the default mode network, a resting state of inward reflection, mind-wandering, and autobiographical processing. This is not wasted time. This is consolidation time, memory formation, creative insight, self-modeling. The average American adult now checks their phone 96 times per day. That is once every 10 minutes. Every interruption collapses the DMN. And in a 2024 study in cognitive neuroscience, researchers found that adults whose DMN was chronically disrupted showed reduced capacity for episodic memory, the kind of memory that makes you feel like you have a self. You are not just distracted, you are structurally becoming a different kind of thinker. Here is what the research actually recommends. Not wellness influencers, neuroscientists. The hippocampus and prefrontal cortex grow under one specific condition: when you challenge them with tasks that exceed your current ability. Learning a new language, a musical instrument, complex spatial reasoning, navigation without GPS. Not apps designed to be easy. Difficulty is the signal that triggers plasticity. The brain does not build what it does not need. This one surprises people. Neuroscientist Marcus Reichel, who first mapped the default mode network, found that the brain's most sophisticated processing, integration, creativity, self-reflection happens during low stimulation states. 20 minutes per day with no input, no podcast, no scroll, no ambient content. Just the brain doing what it evolved to do when left alone. The 2026 AI paper made this explicit. The difference is not what tool you use, it is how you use it. When you consume information, whether it is a video, an article, or an AI response, stop, recall, reconstruct, argue with it. The elaborative interrogation technique studied at the University of Wisconsin shows that asking why and how about new information activates hippocampal encoding pathways that passive reading simply does not reach. You are watching this video. When it ends, pause. What did you actually retain? Can you explain the London cab driver study to someone else? That friction is the point. The science is settled on one thing. Your brain is not the same as it was 5 years ago. It adapted, It pruned, it optimized for the exact environment you gave it. This is not a cause for panic. The same mechanism that allowed it to change is still active right now. The question is not whether your brain changed. The question is whether you get to decide what it changes into. The elaborative interrogation technique shows that asking why and how activates hippocampal encoding pathways that passive reading simply does not reach. You are watching this video. When it ends, pause. What did you actually retain? Can you explain the London cab driver study to someone else? That friction is the point.